And hello from Walla Walla, Washington, home of the Little Giant Vacuum Cleaner Company and Bugs Bunny, a town so great they named it twice. Hey, it's pretty nice here. How you doing? Now, I put this microphone, pinned it to my shirt, and we'll see how that works. And it's very difficult in here because it's actually probably smaller than it looks. There are extremely sharp machinists watching this channel, and I thought I'd go on with some of this just to for amusement and interest on solving some problems. Okay, this can be applied to something like a hydraulic pump or a gearbox, you know, or a combination thereof, because this is like a pump and a gearbox. Now, when I was really young, this style here was my first motorcycle about, I don't know, late 60s. And the reason was they were just dirt cheap. And I managed to find one with a busted transmission that didn't break the cases, and got some parts and got it together and rode that around for a while. It's the K Model, Harley Davidson, and I'll show you some kind of close-ups of this thing, and it's pretty interesting. Now, this is the first unit construction where before they'd have a separate transmission, and on those motorcycles there's a post that goes between the transmission and the motor. So in a unit construction, they build the frame around the engine. And it's a cleaner thing, but it makes the engine a stressed member of the frame. So it's always going to be a problem, especially something an antique like this. So they made this in 1953, and what am I going to say? This is the start of the Sportster, the XL, the XR 750, and others, I guess, along that line. And they had a racing version of this called a KR, and this is just a plain, their plain Jane 1953 K. So I'm looking at this thing, and what happened was a guy came in with this into my shop, and the engine was built, and he had it rigged in the frame. The bike wasn't all together or anything, and had the oil tank hooked up, and got oil in it. Put oil in the primary side, and then it just started leaking out of the motor. And he brought it in and wanted me to check it out. And the first thing that I noticed was that it had been welded here. See? Been broken and welded. That was visible. And I says, well, it's been welded, and it's warped the cases, and that's why it's leaking out everywhere. And so he says, well, then I found another thing on it, and then he says, well, I don't want to put any money into this. It's just going to be too much. And he had other similar projects he had one of these that was running, and he picked this up, and then he was putting together the later overhead valve. Now it's a flathead engine, and the less flathead and most advanced flathead. And this was actually a pretty good engine and pretty hot. It won flat track races up into the later 60s, beating out the overhead valve. So I don't know, there might be a lot of reasons for that I don't know. So this is just a crazy project. And the first thing you have to do, and let me get those pieces together, and I'll be right back. Okay, got the cylinders off this thing. Now, when you're dealing with one of these, the critical thing is that the crankshaft, there's one there in the axles and lathe. It'd be a little smaller than that one. No, this is the small engine. Fits through there without bind at all and as square as possible. And that just only makes sense. So to align the bearings, that's where the lapping tool comes in. Let's see, get that back here. This is the Kent Moore lapping tool. Okay, so it's piloted on the other side by a main bearing. It's a Timken on that side. This is the first Harley Davidson engine that used a Timken bearing on the left-hand side, 1952. They did it on the Big Twin in 1955. And otherwise, engines have straight rollers on both sides. In play of those flywheels and crankshafts controlled by thrust washers. There's no thrust washers needed because it has a dual Timken bearing, and the sprocket assembly pulls it tight and eliminates in play, limited to the spacer between the Timken bearing. Okay, now what this does here is, first thing you do, you put recommended Clover grade C. Yeah, stamped in the lid. This is an old can of, I guess it comes in plastic tubes like everything else. And it lasts a long time. So you run the lapping tool through, and you rotate it through, and you do a back and forth motion. And you can tell when things start smoothing out, it gets less bumpy. And you keep going for a little bit and get it so it's looking smooth. Then you pull this out, put this in a good spot, and wipe the bearing clean, and you look at it'll leave a crosshatch. Then you look clear around, and you want that crosshatch even, and that means that this piloted lap has made complete contact, and the main bearing journals are in line. Now, when I disassembled this engine, because it's leaking like a sieve, I noticed that the transmission had a bind in it. I couldn't get it. It's like the gears are squished together a little bit. And something like that does not work itself out. So let's examine this a little bit further. So these crankcases split right down the middle, okay? And they're located with dowel pins. Dowel pins hold this thing together. Keeps it in position. So I'm looking at the cylinder surfaces here, and there's quite a step here where this side is quite a bit higher, a pretty good step. And then it starts diminishing to nothing here, or whatever, a little almost level. So that means that this side is somehow rotated over a little bit. It's like it's cocked a little bit this way. The main journal's in line, but the main shaft and the counter shaft, which is here and here, are not in line. So, it's like twisted there. So I'll flip the cases around and we'll look at it further. Wouldn't you know it, I found the problem. Okay. So on the bottom of these, there's production numbers. And this one is 5531680. This one is 552, kind of smushed in a 9. You could probably pull them out. It's not necessary. It doesn't matter. And then actually looking at them here, I think this one's really discolored from the welding, It's welded here. You can see the welds. Okay, we'll get into that a little bit more. So right off, these cases were not machined together at the factory. Now, this is where things can get dicey. And I've always stayed on the right side of it. It's really easy to forge these numbers. And it used to be not illegal, but it is definitely illegal in the state of Washington to change any number on any part. So don't ever fall into something like that. Well, this machine, this motorcycle will be worth another couple $1,000s if the case is matched. Well, don't fall into it. If they're going to do it, let them do it. Okay, don't get yourself involved in anything involving any numbers, okay? I can tell you some other learn not to burn things too with these. So here's the problem. They weren't machined together. So what you gotta do is set these up, and those two dowel pin locations, you can shift them by boring them out, putting oversized dowel pins in it, or relocating the dowel pins. So you shift the the dowel pin locations, and shift half of the case, rotate it to where it needs to be. Okay? So to do that, you have to set the cases up correctly. And this is where it was very helpful to be an experienced machinist before I went to the factory school. And I'll show you a little bit of that real quick. Well, it's difficult to blueprint a Harley Davidson engine, especially because never would Harley Davidson release a blueprint for a kickstand. So anything that is blueprint, let's say, was measured off existing engines like this. Now, I talked about having the machinist experience. I knew my way around the shop. I ran lathes, mills, grinders, and stuff before I went to the Harley Davidson school. And I knew the right questions to ask. I worked in the dealership for 2 years and run into problems. We had a mill and a lathe in there. That's one of the things they did sway me to get in there. So this is the question I asked. what's the best way to set these things up in the milling machine and get my dimensions right and stuff like that? What's the best thing to do? And this was the machine shop instructor at the Harley Davidson factory. His name was Chet. And he was older, and he was from the Panhead days. Now, this is a time when it just changed from ownership of AMF, and John Davidson was chairman. And so all I can give you on that is kind of a glimpse of time. And it could have changed radically at any time. So this is how it's set up, and I observed it, what they let us see at the Capitol Drive plant there in Milwaukee. This is how you line the cases up on the milling machine, and it makes sense, and I'm going to tell you why. This rear cylinder surface here is more stable than the front, see? It's just kind of a more meat thing there. It's more supported. So you use the rear cylinder surface and align that up with your x-axis. So then you take your measurements. Now, the jigboring machine works best for this, but you can do it with your DRO in a good Bridgeport. So there's that, and then you go off the center here of your main bearing, and then you base all these other holes there. You want to, the best thing to do is measure as many of these things as you can get in that way, and write it down where these hole locations are. Because there's a lot of inaccuracies in these old engines, and you'll get a better average. And then when you're checking stuff out that seems to line up, you can, solve problems on it. But like I say, excuse me, I'm going to come back in a second here. I got a cough. Okay, right back after a good cough. I remember exactly where I caught that cold. Walmart. Okay, back here. So the machinists here will know what I'm talking about, mirror imaging. Now, the cases here are held with the dowel pins. And let me grab that other case. And I'll set it up here. Here's the dowel pins. So what we have to do is shift these dowel pins as needed. And so we put up the, in the jig board, so that's what I use too. It's more difficult than a Bridgeport, but it can be done. But it's a lot more accurate in the jig boring machine. So, oh boy. So you put these things together too, and you note how much offset. So the first thing you really do is have the thing together, have this case on top of that case, or you can just slip this case on top, right? And then check this hole, pull it off, and check that hole. Then you can decide how much to rotate these things over to help bring the transmission bores into register. Now I want to point out on this is an early type of this engine. And on later models, they had a trap door here. And you could pull the transmission out. And these had weak transmissions, and to work on the transmission, you had to completely disassemble the engine, take the cylinders off, everything. But they put a transmission door in there later. Okay, so back to this. Okay, you got a mirror image. So you find how much offset you have, and then you find where the dowels are, and then you tweak the distances needed to move these dowel pins over. And if it's just a little bit, I'd make, out of drill rod, I'd make oversized dowel pins on the Monarch 10EE. Or at one time I used a heavy 10 South Bend that I could whip this stuff out on. Make my own dowel pins. You can make double size dowel pins and stuff like that'll drive probably mechanics in the future nuts. Now, what's going to happen here is because of the welding on this side, you can see it just had a bad interface there. The other case is welded here on this side, and it leaked everywhere. So I'm going to have to take this case and face that. You know, you have to face all these sides. And you have a considerable amount. I'm not kidding you. You can cut easily 1/32 out of these things, you know, on mating surfaces, and squeeze it together. And it can get so severe to make something like this work. You end up grinding the gears and stuff like that, the sides of the gears. And the tool and cutter grinder, you'll see that machine in the pictures of the shop I had in the early 90s. Now, in the early 90s, I worked on motorcycles and stuff like that and did a lot of different things. But insurance suddenly jumped back then, and it got so I could not work on motorcycles anymore because of the rise in the insurance. So then I just go, well, heck, I'll just do the machine work. Then, and at the same time, some other people jumped in that wanted to do that kind of service work, so things worked out pretty good. But then they wanted to have their own machine shop, and that didn't work out too good for them because they weren't good machinists. So that's what's got to be done, is set these up like that and mirror image it and shift these over. And, you know, stuff like that can be done on industrial gearboxes or whatever you have. Okay, I thought you might find that interesting from the machinist point of view. And I'll come back with some more if you're interested. I like the questions. It's interesting. Okay, have a good day. In the 90s, I was doing Evo and shovel head engines for the dealerships, for several dealerships. Part of the dealer network you get into if you get certified. And so that was a boon, you know. The reason I got out of the Harley shop here is the company forced the shop out. And that's when they started doing the superstores. So they forced the two local shops out. And I'm not kidding, it bought them both out $125,000 each in about 1985. And then a car dealer, of course, took over, had the means and the finances to build a $2 million building to house all of the gewgaws and stuff, you know, the clothing and all that stuff. And they had specifications on everything like that. So that's how the mom and pop shops got pushed out. And the shop I was involved with was so small that sometimes during the winter, we worked on tractors. It's out, the place is out in the country, and I'll go out there and show a picture of the building. It's still there in a little town just outside here, a little town of Dixie. So anyway, I'll get into the jig bore thing here. This is really an ideal machine to use to deal with Harley Davidson crankcases. They even had a jig bore in the old factory building there, in a developmental part there. They still did machine work at that Juneau Avenue location. I think it's just total offices now. And but anyway, the advantage of the jig bore is it doesn't have a knee. And you see the table's just sitting on the base, you know, the X and Y, and the movement is up in the head here. And this is called the spindle housing. And it glides up and down those fabulously unmatched Moore hand-scraped ways. This machine here is the same vintage of that motor. And this cost a lot of money. You know, I think someone mentioned to me that they were about 7 times more expensive than a Bridgeport. But at any rate, the Bridgeport accuracy is in the thousands, you know, plus or minus 1,000. This is 10 times that. It's plus or minus 10,000s. But there's a problem, and that's the spindle bearings. To be so accurate, the most accurate made at the time bearings were used, and they're grade 9. And you can't just switch the bearings out. And because there's a custom preload, and you can call any bearing manufacturer and talk about custom preloads, and they're going to say, don't do it. The reason this machine can get away with a double preload on the spindle bearings, so it bores so accurately and holds itself together and doesn't shatter on tough alloys, is that preload. But that preload shortens the life. So you can't just change the bearings, because the bearings they made back then are not the bearings they're making now. The bearings they're making now have one more ball. So if you use the same preload spacers, you're going to go above the preload, and the machine won't last very long at all. It'll do a bad job from the over preload. And I did a video on this. If you search more jig bore, I kind of go into that direction. If you're interested in that, if you need that information, you can contact me by email, and that's off my home page. And I had a phone, but I had to ditch the phone because too many calls, and I had people, just weird people calling and stuff, so I ditched the telephone. But you can get a hold of me by email if you have any questions or something regarding the Moore Jigboring, okay, because I did replace the bearings in this Moore Jigboring, and it was, I don't know, it took the last of the hair off my head, maybe. The problem is the cost of those bearings, and you got to do extra handling. And it's a tough deal if you've never worked with precision bearings before. Okay, so I'll be back, and I hope you got a kick out of some of this. Button.